Degraded or degrading pastures with few nutrients or in eroded soils. To different extents, 2/3 of all pasture areas in Brazil are in this situation. This problem has socio-economic and environmental consequences. 30 million hectares of degraded pastures. This is the size of the area to be recovered until 2030 by Plan ABC+, a policy aimed at adapting to climate change and reducing greenhouse gas emissions by agriculture and animal husbandry. And what are the economic, social, human, and environmental impacts of this recovery? Evaluating those impacts is the purpose of TEEB for agriculture and food projects. But then, how does the recovery of degraded pastures work? In short, it is the direct recovery of pastures through practices aimed at recovering soil cover and the vigor of forage plants, or others aimed at fully recovering an area. RDP might be also accompanied by crop livestock integration, CLI, a kind of technology aimed at indirect recovery by integrating pastures and temporary crops. This study assesses the impact of both forms of recovery until 2030. In the first scenario, only RDP is implemented. In the other, CLI is also implemented. Both are compared to a baseline, a forecast considering recent trends in land use and productive systems. In 2030, most recovered areas would be in the largest rural properties, a total of 10 million hectares. Whereas a little over 5 million would be recovered in the smallest ones. A similar dynamic would happen with CLI. Now let's look at the impacts of this recovery. With 13 billion reais in investment and 131 billion in funding, pasture recovery would positively affect Brazil's GDP, which would grow between 1.3% and 1.62% until 2030. This growth would happen in all regions, especially in states where animal husbandry has a large share of production values. Less developed economies would present bigger real GDP growth, contributing to more regional GDP equity. These numbers would also lead to social and human impacts. The greater availability of cattle products would lower their prices. The increase in economic activity would push up real household wages, especially for more skilled workers. This would increase consumption in most households, especially of food. But although all sorts of households benefit from the implementation of this policy, gains would be less significant for poor families. Besides lower wage gains, less qualified workers would also face a lower job supply. That is why we must think of complementary policies to fight inequality, which contribute to making these workers more skilled. Pasture recovery also includes some positive environmental impacts. Good quality pasture bears the potential to fix carbon in the soil to a point in which it compensates for the increase of methane emissions caused by growth in cattle numbers. Greenhouse gas emissions drop by nearly 29% in beef cattle husbandry and by 15% in dairy cattle husbandry when we take carbon fixation into account. Emission intensity by kilo of meat and by liter of milk also drops. With a higher productivity and a better land usage, the demand for new pasture areas would fall in nearly all regions. RDP would not be enough to reach zero deforestation compared to our baseline scenario, but we expect to reduce the projected deforestation of native vegetation in over 6 million hectares, or over 7 million hectares if CLI is also adopted. The recovery of degraded pastures would also improve soil conservation, reducing erosion in both scenarios. On the other hand, the indicators evaluating native vegetation quality would not improve in several states. This requires policies with a holistic territorial approach which creates wildlife corridors and ensures the enforcement of Brazil's forest code for a really low-carbon and ecologically efficient agriculture. Despite the need to develop mechanisms to provide a better distribution of the benefits of Plan ABC+, RDP has the potential to increase the GDP, increase household income and consumption, conserve the soil, preserve native vegetation, and reduce the number and intensity of greenhouse gas emissions. This is the challenge for 2030.